Welcome everyone again. We were gonna talk about how to do pen testing for AI and talk in general about the pen testing process and how AI integrates with it, how it impacts organizations, and a lot of other subjects. With you, one sec. Can you hear me?
Yeah.
Avi, can you hear me? Okay.
Yes, we can hear you.
So with you today is me, Nikita. I'm a team leader of the pen testing team at Scytale. I have 5 years of experience with pen testing of various different systems and components. And Avi?
Yeah, so I'm Avi Lumelsky. I'm from Oligo Security. I'm an AI security researcher with around 10 years of experience, both developing and researching things. And in the past, before Oligo, in my recent job, I worked for DCAI, which is now NVIDIA, on optimizing models, specifically the inference part and making them run faster. And now I'm researching the security aspect of production workloads that include AI in them and report security vulnerabilities to various companies.
So, first of all, let's ask, how is your organization currently using AI? You can interact with the poll and put your status there. While you're answering, just so you know, a few things, we're recording this meeting, this webinar, and it will be in LinkedIn as well. It will also then appear on our website. And
we welcome you.
Yeah, feel free to ask questions in the chat. We have a few stops, or maybe one stop that we will take and answer those questions for you as best we can. Okay, so I'm seeing that there is some integration there. Nobody answered that they're not aware of using AI, which is already good.
Yeah, everybody knows what's AI these days.
Yeah, it's very common technology. One of the fastest growing adaptations of a new technological revolution that I've seen personally.
Yeah.
So let's talk about AI in general. What is AI? We can think about AI as a statistical model that predicts the best way to answer something that you asked for, depending on the type of input and the desired output and the optimization and configuration of the AI itself. In contrast with regular software that we're used to, the answers that the AI gives is not the same every time that we ask using the same kind of input, because the code is not as deterministic as regular code. So that we can get different results depending on the training of the AI model and just the calculations that it does on the back end at that moment. Let's talk about
and just for comparison, Nikita, I just want you to guys think of like testing. So imagine you write your software, you wrote some tests, and then you expect the test to pass all the time. But with AI, the model would not provide the same output twice in a row necessarily. And you simply cannot take this fact for granted. Like software used to behave in a single way. Now we use AI as building blocks in other parts of the software. And it's simply unpredictable, and it's something just to have in mind.
Yeah, exactly. And let's talk about the terminology that we're going to use during this talk, so that we're all familiar with different types of AI and everything. Starting with GenAI, that's the one that's being most currently marketed, let's say. It has the ability to generate content that we're asking for. from a prompt or some kind of input that we're putting into the system. Important thing about GenAI is that it can only display things that it learned from its learning source. It can't still imagine things or let's say make up for lost information, something that we can do in our minds. So some hallucinations do occur there, that they're sure that they generated the correct thing. We have LoRa's, which are low-rank adaptations of the models that we use. The difference with LoRa's are they're used to, let's say, keep progress from previous implementations of the AI, and they're packaged into a lower-rank adaptation of the same model that was trained, and improvements to that AI system are built on top of it in many cases. It requires less resources to run because it's much smaller and it's less complex, but it still gives out a good percentage of the quality of results, around 80% to some estimates. But they're not easily readable, let's say. You can't really know how they were configured before that just from seeing the model itself. It's already prepackaged in a, let's say, black box format.
Yeah. And this black box, by the way, is like billions of parameters complex. So the larger the model, the harder it is to explain why it outputs the tokens that it outputs. In other words, why it works this way. And this is a very big field that is still under research. Many things are still not quite obvious in the way that models work today. But the beauty of it is that it simply works, and sometimes you don't have to deeply understand how exactly in each step of the phase, like how the tokens look inside the model. But the idea is that using like low-rank adaptation, you can very easily change the performance of the model or fine-tune it using much less computational resources and spending less money. And that's GenAI. So when we're talking about low-rank adaptation, we're talking about taking a very big model and adapting some parts inside its weights to work better on the task that we defined in advance. And you can use multiple LoRa heads for a single model. So it basically like a fine-tuned, slim version of the model that is specific to a given task. And you can have many LoRa implementations for specific tasks. Some of them can be summarizing, medical paragraphs, or some of them can be even related to, generating new text and not like summarizing. But the idea remains the same. You have a big model, you want to fine-tune it to a specific task, and LoRa is one of the leading ways to do it these days.
Yeah, also makes it easier to implement on local machinery that you can use, right? Let's say you use it on a laptop right now, not some kind of gigantic super server.
Yeah, you can actually fine-tune models on your laptop, which is amazing.
Then we have QLoRa, which is pretty much LoRa's but quantized, which means that they use it's used with a method of trying to slim the model even further by quantization. A good explanation I got, like a, let's say, common way to understand quantization is the same as trying to give the directions to a screen to produce color. Instead of storing all possible color variations, each with their own name and value, you can store the base colors and only store the directions of how to get to that hue. Then we have the most famous word, LLM. Large language models, we all know them, ChatGPT, Gemini, although they also have other functionality, but the main use of LLMs are predicting the answer or answering questions, right, that the user asks immediately.
Like a chat interface is like the first application. If we'll be honest, so we all heard about generative AI or the word LLM for the first time most of us heard it for the first time when ChatGPT went out, right? And it's been a while, but it's crazy. And what they did, like the first thing that ChatGPT did better than anyone before, and the first like a huge application of AI in a chat is basically fine-tuning, like if we take LoRa, for example, but fine-tuning in the same way that LoRa fine-tunes and adaptation works, but for the entire model to follow instruction that users provide to the model. So ChatGPT was actually using reinforcement learning based on human feedback to follow instructions. And so this is like the first big application of an LLM. And that's what like OpenAI is crazily famous for. And that's it. I just wanted to say that like LLMs, we all think about like OpenAI, and they were the pioneers, but we have so many companies that build foundation models, which are the large language models. But you also have like vision models, which Nikita will touch in a second, and small language models. But LLM is like one of the terminologies that we use on a daily basis to describe all of those.
So vision models. Vision models are the ones that you can recognize maybe from mobile phones if you dive into that subject. The image that you get on your phone is not the image that was immediately captured. It goes through processing that is using a trained artificial intelligence model that optimizes the image to what it was trained that people would like to see as a result, which is, I think, the most relatable example.
Yeah. Also, you have like nowadays, it's pretty new, but you have some models that are vision and language, like multimodality is the terminology to describe these models. So they support more than a single input, and they support more than a single form or type of output. So they can either get text, video, photos, or audio as input, and the outputs are the same. They can be either of those. And that's it. Just wanted to make sure that you understand these things get more complicated as we progress and as time passes.
Complicated and futureful.
Yeah.
Then we have the experts. Expert AIs is just a fancy name of an AI that was highly customized to a hyper-specific task. Something very, very specific in a larger format than a standard like LoRa to give the best, most accurate answer on some type of subject. But this term specifically is being used a little bit differently with each time that you could talk to someone about AI. So that's the way, let's say I see it. It's the most commonly used one.
Yeah, definitely.
So let's move on to the standards. When it comes to compliance, we're starting to see frameworks appearing for standardization of how to implement AI, how to develop AI for companies that use it or for companies that create it. We have ISO 42001 and EU Artificial Intelligence Act. Both of them approach the subject a little bit differently. I'll briefly touch on it. The ISO standard is very similar to the ISO 27001, which is the information security standard. It almost follows the exact same template, let's say, same skeleton, but it's a little bit different, adapted for AI, obviously. And the EU Artificial Intelligence Act treats different types of AI models in different ways and requires different things from them. There are unacceptable AIs that they don't allow at all, which if you're interested, you can put the questions in the chat. We can talk about them later. There are high risk, medium risk, and low risk models. If you want to be compliant with the standard, you need to first recognize what type of AI you're using or developing, and then go through the standard. Moving on to SOC 2. Implementation of AI or development of AI also ties into SOC 2. AI poses interesting challenges when it comes to compliance with SOC 2 and ISO. And the reason is that this is a completely new technology with different security controls that we're not used to, and are not. There's almost no blueprint of how to secure everything because it's so new, it exploded so fast, and we're still reacting in terms of how to implement security on everything. It went from 0 users to hundreds of millions of users in 3 weeks, literally, and we're still playing catch up.
Yeah, if you want like a proof for that, by the way, if you would have looked at the stars that Kubernetes has, or that very like not old but relatively like well-known technologies have, so some open sources in the AI ecosystem reach the same amount of stars within 1 year. So that's how fastly adopted this technology is.
So briefly going over SOC 2 and ISO specifically, the main challenges I see that relate to pen testing specifically is the implementation of access control. It's very easy for companies that implement this technology to just let it train on all of the data that the company has and then specify, let's say, in a prompt or some kind of way of, let's say, don't disclose this type of information to this type of user, which is the, let's say, most simplified but most common way to make that mistake. As pen testers, that's the first thing we do is try to understand what we're not allowed to do and how to bypass it. And in many cases, for this stage, let's say, of the technology being implemented, it's very easy. There are other challenges where it really interferes with the way that you can be SOC 2 compliant, but or ISO compliant. But we can go into that if you want. You can again put the questions in the chat and we'll answer them a bit later.
Yeah. So regarding like secure development lifecycle for AI applications, the idea is that like any other kind of software, AI is an application at the end of the day. So it lives in a certain environment, but before it reaches this environment, which might be production or research environment, as a running application, we have it as a code. Now, I want you to just have a few rules of thumb when working with AI, or if you manage security teams or compliance teams that have to secure these applications. I want you to take the following into consideration. So the first one is that the majority of AI code is open source. So you have a huge risk of supply chain compromise when working with AI software. And that really complicates things because on the other hand, we have a lot of new code, a lot of new lines of code that people without security orientation wrote this code, and the same people are usually reviewing the code without security or compliance in mind. So to them, feeding data to the model is very obvious, but they don't have in mind where the data is later stored, what happens with the data, and as a result, they are really easy on the trigger when it comes to adding a new technology or a new dependency to the code. So the first rule of thumb regarding like secure development of applications is start by understanding and thinking 2 or 3 times before you add a core dependency to your project, which is AI related. First, because as I said, the code is relatively new, but it is also, it was not written by security practitioners, so you should just consider it unsafe until proven otherwise. And later on, after this application lives and this code reaches production or your application as an SDK, or it does not matter, you always have the risk of supply chain, as I said before, because AI applications are 99% open source. The code is so new, and the technology evolves so fast that you simply don't have an option. You cannot use AI without using open source software. You simply cannot. So you just have to be very delicate in the places that connect the model, like the AI itself, and the rest of the system. Like this part, I would recommend to review it with much more security in mind. And just understand that you have implications on the locality of the data. So applications, they communicate, they do all sorts of things, and you just have to understand that whenever you share some piece of data with an external service or with an AI application, it can do stuff with the data that you simply are not aware of, and it can really hurt compliance, and it can be a big pain to some companies. So visibility into which software I use inside the application that is related to AI and anything around it, I just recommend to review those several times, and have in mind that basically supply chain is one of the greatest risks in AI because it's so new and you have to use open source. You simply don't have a chance to implement it successfully without using open source.
And those complexities you discussed really tie into the last point, the penetration and QA of the code. Penetration testing for this type of technology is a little bit different when it comes to how different companies view that technology when implemented in their solutions. Let's say, usually when you add a new page to your application or some kind of input field, it maybe makes the pen test a little bit more complicated, a little bit longer, but it's potentially vulnerable to the same types of vulnerabilities that we already knew. So it's not really adding a lot of complexity to the testing procedure. When it comes to specifically AI, the complexity is exponential, because the more data it's exposed to that we can't know as an external tester, and the more featureful the AI is, the more tests we can conduct. And there's a whole methodology, not shorter than the standard, let's say, web pen testing methodology that we need to use and test the AI, especially referring to something that you said in the start, that the same input can result in different outputs. That means that we need to conduct the same tests over and over and over again during each engagement. And that really impacts the testing procedure as well. Let's move on.
Definitely.
Because we're diving maybe too deep into this. So let's talk about the risks of AI models. We already mentioned them. The attack surface of AI models is very varied. It all depends on how it was implemented, what it was exposed to, and what type of functionality is enabled for that AI. Let's go to common vulnerabilities. Avi, maybe you take this.
Yeah, so I want to share a bit about the past year as a researcher. So we found in Oligo, we found vulnerabilities in each and every AI framework or library that is in use by corporates. And the reason we found is that we simply looked, and we were the first to see it. As I said, this code is so new that it must have bugs. So it is even scientifically proven that the amount of bugs or the amount of vulnerabilities, in other words, can be present in a certain code base, is a direct result of the amount of lines of code that are written. So new code is simply you can just assume it has vulnerabilities that are way to be exploited. And besides that, there are risks that we saw in each and every one of those frameworks. We call them shadow vulnerabilities. I'll dive into that a bit later on the reason of why they occur and so on. But the results were obvious. The attackers want to affect the state of the application. They want to be able to change the application's behavior to do things that are not intentional by the developers, but are allowed, unintentionally. We can talk about adversarial attacks, where you can manipulate the input data. Many times it's simply referred as a prompt injection. But the idea is that you can know how an LLM, or even a specific LLM, let's use OpenAI ChatGPT, for example. So you can know that ChatGPT leads to certain output by when receiving certain input. And if you study this this attack surface, like only if you look at the inputs and the outputs of the model and you try to predict or understand what leads to those responses, which parts of the prompt. So you can actually engineer a very specially crafted prompt. As we've seen many times around the internet, people have managed to go ChatGPT, like make it go wild and simply output stuff that are incorrect, or use it for malicious purposes, such as I don't know, writing a biased post for social media accounts. And there are actually, if you want to dive into that even more, so OpenAI, Anthropic, all the big companies that train those big AI models, they release a monthly or bi-monthly report on how nation-state actors try to use their platform and to leverage it to do bad things. So it's all out there. I'm not making things up. And the adversarial attacks are the first like things that these threat actors look after, because they can control them at the moment without any special credentials. They basically use the simple ChatGPT interface or the Anthropic Claude interface, and they feed it with inputs and get the outputs they need. And many times the providers try to block certain prompts. You might experience it yourself, Nick, when you ask for something that's simply not legit, or can cause a biased output. So models tend to refuse. So you have like, it's even a metric. So you have a refusal rate, like how many times a model is refusing to do what I'm telling. So we expect it to refuse all sorts of things, but most of the times when I was looking on a new technology or a new model that went out, so it took some time to fix all these adversarial attacks and to get it stable. Like when OpenAI releases a new model, so it takes some time until they can control the guardrails of the model, and like 1 or 2 months after it's released, it's much more safe usually than the second that it is released, because they put some walls before the model and after the model, and they try to make them higher, these walls. You can think of it as a firewall for like placing a firewall for the model. Like it might be a correct terminology, but like based on something that is similar. And these adversarial attacks basically just use the inputs and outputs of the model to exfiltrate data and basically abuse the model to do stuff that it should not. We also saw model poisoning attacks. So in open sources such as Ollama and PyTorch TorchServe, which is another big inference server by Meta. So we reported to them about model poisoning attacks that basically enabled any attacker without special privileges to replace a deployed model. So they can basically change the responses that your users are receiving, and it's a big problem. They like can inject content. They can change the way that your users communicate with the model. They can even like hurt them in terms of like providing them like offensive output. But if we take into like medical imaging, so they can even like you can translate it to like hurting human life, and the consequences can be very severe. So imagine you have a hospital that is deploying many AI models, so it has to keep them safe. And imagine an attacker being able to replace a model, or if you think about like a traffic system, so imagine a model being able to replace the color of a traffic light. So we've seen that using like in one of our researchers, this was the POC that we did to make the company understand how big the issue is. And the final one is data leakage, and it has a lot to do with the compliance. Basically, data is one of the first things you should look after, and is the most risky part around models. So it's much more common to be able to exfiltrate data, while executing arbitrary code might be a little bit harder because you have to have a vulnerability for the code base and the software itself. But data leakage, just by the nature of the LLM, it is basically unpredictable, as Nick said at the beginning. LLMs are connected to all sorts Sorry?
And uncontrollable, basically. As long as it was in the training data, we can assume that it can be accessed.
Yeah, so if the model trained on specific data, so you should simply assume it knows some facts from this data, and it can always output the data in a raw structure. So they are you can reverse engineer models and understand which data they were trained on, and even exfiltrate the raw data sometimes. You just have to keep in mind that models are part of real-world systems. They communicate. They have to pass data to some APIs. Like imagine searching like a weather API, which is a classic example. So if you share the name of the city with a weather API provider to understand what's the weather there at the moment, and feed this data to an LLM in real time, you just have to assume that the weather API provider can hold this data, and you have to understand that it's an issue in terms of data locality. You share some data, and it might be obligated to some regulations. So just to keep that in mind, data is connected. You have two levels of data connectivity to an LLM. The first layer, the way I see it, is the data that the LLM was trained on, and this is simply something that is there forever. And then you have the APIs or the context that you feed the model in real time, and then you might enrich it with, I don't know, a record from the database or stuff like that, and query an external API, receive some response and include it, and feed that to the prompt. It's also called the retrieval augmented generation, or simply RAG. And that's it regarding common vulnerabilities. I'll deep dive into some of them later on. And also on the real-world examples of AI breaches, and we'll focus on the major vulnerabilities.
Yeah, so moving on, the way we already discussed in the last slide, how attackers exploit AI, there's an endless amount of ways that you can do that. Some of them are more technical and code-based. Some of them are just general input or output validation misconfigurations. Some of them are just overexposed AIs that have access to excessive information for the type of customer that's going to use them, or let's say consumer in that point. Avi also discussed the supply chain and deployment risks, which are one of the most untreated, let's say, types of vulnerabilities. They're more invisible, they're harder to touch with your hands, so they get less attention, and that's why they're less fixed in most cases. We'll go to a few security incidents.
Yes, so remember I mentioned the term called shadow vulnerabilities. So like shadow IT or shadow machinery, so we have a lot of vulnerabilities which are not really classified as vulnerabilities because they are intended behavior. So one thing to keep in mind when using and implementing AI inside a given repository or a product is that you have to read the docs more than ever. So if you thought that reading the documentation and the warnings was important, and I'm as a developer, so I sin myself, and many times I don't read the docs, I admit, but actually that's where the gold mine for attackers is present. The doc says it all. So if something is insecure, or if you have some behavior, most of the time it is documented, and it is well documented if it's important. So in this slide, you can see many Python, JavaScript, and so-called frameworks or libraries that are in use in many AI applications like NumPy, Pickle, Joblib, Tensor, like Torch, like PyTorch by Meta, Pandas, and so on. So you don't even need to work with LLMs to use them. You simply need to use data science related stuff, and of course LLM and AI generally apply to data science as well. They're part of the same world, and these libraries are very prone to exploitation. And we managed to use each and every one of these screenshots and do something unintentional in a big project used by the world's largest organizations. So if you don't have currently a CVE, if you don't have something that specifically alerts you, here you have a problem in this application that is related to AI, you should not assume that you're like 100% safe, because your developers are not reading the documentation, and many times unintentional behavior might surprise you. And let's see how we can go. So the idea is that we have the model and we have the infrastructure that it runs on. So the model itself is the provider. It can be a SaaS provider such as OpenAI, Anthropic, AWS Bedrock, NVIDIA Cloud. It does not matter. But you have a model provider. You can even run the model yourself if you have the compute and the GPUs required. You can even host it on your own infrastructure and have the data staying inside the organization and not share it with anyone. But it's a bit more complex engineering-wise, and running these models is very costly. So many companies simply use the API, the SaaS APIs offered by these companies. There are pros and there are cons, but I just wanted to emphasize that there is one part in the deployment, which is the AI provider. But you also have the infrastructure that it runs on, whether it's OpenAI's servers or NVIDIA's GPUs that hosted at NVIDIA's cloud. They can be wherever they want, but the idea is that you have software that is connecting your AI model and the hardware. Without this software, models would not have run. And this is exactly what I'm focusing when researching things. I'm looking at the connection between the AI model and the infrastructure, the code written by developers, by the open source community, that connects the model to the hardware itself, to the bare metal. And many times this code seems okay, but it has tons of vulnerabilities which are simply there. If you would have read the code, which I bet many times you also do, but the idea is that you would have spotted it. Like it's right there. It's just that many people are not looking at these projects because they simply assume they're too new or not adopted enough in order to begin with the research. But here's a simple example. So we have this Jinja 2 library in Python. It is used by Flask and Django and many other like well-known frameworks for developing web applications for the past like 10, 15 years. And we have this vulnerability from 2015. You can see it in the Twitter thread at the bottom, which basically says that when not used correctly and the default way is not safe. So if you would have followed the documentation of this open source, you would have ended up being exploited and being like vulnerable to remote code execution. And on the left, we have a payload, which is just an object that if I had a web application and I would have fed this object in one of the form's inputs, it would have run arbitrary code on the server that runs this templating engine. And in 2024 alone, so we had 2 incidents. There are even more that are not in this slide, but 2 big projects. The first one is Llama CPP, which is inference code by it's an open source and it's on GitHub. This is like the first inference code that was low level for running Llama models. Llama is a large language model, the best open source model as of today by Meta, and the official like code base that almost everybody uses, including Hugging Face, including NVIDIA themselves. So everybody knows this project when it comes to AI engineering, and this is like a very famous inference server, and it used the same pieces of documentation and guidelines on how to implement Jinja 2 templating engine into the server. Basically, how it is used, it uses it for templating like the prompts, the user and system prompts. So it uses this library to render strings, and then these strings are fed to the model. But they use the unsafe default example. So users were actually like vulnerable to remote code execution as a result, and they were not aware of that. Then we have ShadowRay. So before I dive into ShadowRay, just the same like vulnerability was in Light LLM. LighterLM is also an LLM proxy, basically these two CVEs were published in 2024, 10 years after the initial CVE was released. And people are just following the documentation. They don't carefully read it, and they use the unsafe defaults. And this is exactly what pentesting is supposed to catch, the unknown unknowns, or the stuff that you should be surprised about. So I just wanted to double down on that. And I have an example for a real, the first real attack campaign that was caught in the world on AI workloads. So there is an open source by a company called Anyscale. The name of the open source project is Ray. Ray basically is like Kubernetes to AI. It helps you scale workloads, Python workloads, but not limited to Python. And it's basically like a replacement for the multiprocessing model in Python. So you can just scale any function you want across a cluster of hardware. So it's very similar to Kubernetes in the essence of infrastructure for AI and scaling AI algorithms. Just write your function and I'll take care of it and scale it across the hardware that is present. So this is the idea of this open source. And a small user, OpenAI, they claim that they trained ChatGPT using this framework, which is a bold statement. Now, around 1 year ago, I remind you, it's an open source. So 1 year ago, the maintainers, Anyscale, they got a CVE. A CVE is a vulnerability report by a security researcher. And they chose to simply dispute the CVE. And they have every right to do it. We also understand them. But they claim that Ray should be used only within trusted environments. And it's the user's responsibility to make sure that they are used only in strictly controlled environment, as you can see in the second paragraph. And by the way, the vulnerability was around the lack of authorization. So basically, you have an API, you have a server and a port listening, ready to accept connections. And unintentionally, users were allowed to run arbitrary code if the server is running, using like a jobs API. The jobs API is basically the sole responsibility of Ray to be able to scale things and run jobs on demand. It's like a core part of its behavior. So the maintainers had to dispute it because, guys, this is the essence of this open source. It's supposed to run code and arbitrarily, like on demand. So it's the user's responsibility. But that led to a very big blind spot, and many AI workloads were exploited for several months, and no one knew about it. We have seen AI production workloads that leaked credentials to databases, as you can see, private keys to SSH connections, so you can actually connect to the machines and spawn reverse shells, passwords, and not only that. We also found many tokens that were living inside those applications because, as I said before, it's even like a better way to understand it. So I mentioned that AI models, you have to communicate as part of a larger system if you want to implement them in your application. Of course, they can do something very specific, but many applications have tokens for third-party services inside of them for authorization and to be able to communicate. For example, we found Stripe tokens. So the LLM application or the AI workload had something to do with Stripe, with payments. And for that reason, it had all the credentials to the Stripe account linked to that company. So it could accept connections and use the Slack API, the Stripe API. And basically, whatever your application is doing, once it's exploited, it's available for attackers, and I want you to remember it. So we found many third-party tokens for Slack, Stripe, AWS, and even OpenAI. So we could actually use this, the first two are examples to OpenAI tokens that were leaked as part of this attack campaign. And we're talking about like big companies. I just want you to look at the big logos here over again. It's a well-known open source, and as I said, it's very widely adopted. So many companies were struggling to understand how it happened. And the reason is that the CV was disputed. and the maintainers have every right to dispute it. And once a vulnerability is disputed, you have nothing to do with it, because security scanners and static code scanning tools will simply ignore it because they treat it as no issue. To them, like a disputed CVE is not a real threat. So they simply treat it as a false positive because the maintainer said, look, guys, it's not an issue, but it's not always true. And this led to the first known attack on AI infrastructures at scale. And the outcome of this attack was billions worth of compute. And I did not mention it, but it was for monetization. The attackers reached those companies and managed to install crypto miners. So imagine having a GPU, paying for it, I don't know, several millions. The GPUs of today are pretty expensive. So imagine how you bought a GPU or thousands of GPUs, you connect them together and you have the infrastructure for that. And then attackers are simply installing a crypto miner silently without you knowing, and gaining money on your expense without you knowing for 8 months to 1 year. So we're talking about billions of dollars in worth of compute. And this is only what we know. So it might have been much more than that, but that's just from the time that we were looking at and at the time of researching. And that's it, basically. If you have any questions on anything that I've said about these attacks or about AI vulnerabilities, so of course, you can send them in the questions section, and we'll answer them later. And that's it from my end on the AI exploited in the wild attacks.
Thank you, Avi. That was very informative. Any questions that you have, you can post them in the public chat. We can pop them here, answer them to the best of our ability. Here we have one from a different source. So is penetration testing enough to make sure implementations of AI is secure? No, it's not enough. When it comes to, just disappeared here. I'm only I seeing the.
Yeah, no, 1 second. I'll try to.
Oh, here we go. So yeah, it's not enough for to make sure that the implementation of AI is secure just by doing penetration testing. You have components that you can test during a penetration test realistically, because they're invisible to the tester. Even if the test is done with a slightly informed type of test, it's still not enough. I would recommend doing design reviews, reviews of the infrastructure where the AI is located, and there's also procedures that you need to do, like with automated testing. There's too many sides to an AI system that pen testing would be enough to test all of this.
Yeah, I agree. I definitely agree. I think that pen testing is very important, but you also have to have this security while developing in mind, and just assume that even after pen testing, you need a long-standing solution. It can be pen testing frequently, but it can be also a runtime solution that's already there and is running 100% of the time. So pen testing is very important, and it's an inevitable part of the security work around deployment. Yeah, and that's it. Do you have anything to add on that, Nick?
No. Let's go move to the next question. I have another question from LinkedIn probably. What's the best practices for which agent softwares to use?
That's a great question. Yeah. So
you were saying?
Yeah. So 1 second. Yeah, I'm trying to show it again. Yeah. So there is a question. I'll take this one. Basically, there is no right and wrong answer here. So the true good answer would be it depends on your use case. I would initially recommend developing an AI agent with a specific open source. It can be either LangChain, Crew AI, or other like agentic frameworks. It depends whether it's several agents that communicate and collaboratively work together to solve a task through time, or a single agent that has specific access to several tools. So I personally think that many times these things are overcomplicated, and I would not have used any like specific software. I would have built it with the APIs from scratch, and I would do the connection to the tooling and the available like functions myself. Agents are simply an application that uses an LLM and can act upon its outputs autonomously. That's the idea of an agent, an LLM agent. And there are many frameworks. I think that all of the frameworks are equivalent at the moment, because once a feature is released in one of them, so the next day the other incorporate the same feature. I can't point on a specific leader. I would try to I encourage you to try to write it yourself without any third-party software, because many times it's much more simpler than you think. And adding a new supply chain or dependency, so it just complicates things, and it has more effort than it brings you value at the end of the day. That's my take on like new software that is specific to LLMs.
Yeah, let's see. With another question here, my implementation of AI is not public. Does it pose a risk to me? So it all depends on the context of who has access to that AI. Not public means that could be maybe partially personal. It could be only on my machine. It could be in different formats. So it depends on who accesses the information and what information it was trained on. Even if it's local to only you, maybe the risk is not information leakage to unauthorized parties, but it still has vulnerable components that might be exploited to, let's say, leverage privileges, increase privileges on your local machine if it ever gets hacked, even if it has limited access at that point. Any software that is installed, especially software that is so new and still not completely secured, even on the part of which libraries and components it uses, poses some kind of risk.
Yeah, definitely. I can even elaborate on that, Nick. Like I can just say that we conducted a research in which we call 0000 day, 0000, like 4 zeros, like the IP address. So we found a huge bug in many browsers, like in each and every browser, that enables websites like attacker.com or google.com to access local services using this special IP. And they forgot to block it. And actually, this bug existed for 18 years in all of the browsers. And we reported it to them. And our demo to emphasize the risk, we used Ray from the same ShadowRay story that I've talked about beforehand, and the first like real attack campaign on AI workloads. And many organizations thought that they are safe because it's not internet facing. And we were able to emphasize that even if the software is running locally, or if you run it on your computer, some websites can still communicate with this local software. And if it's AI, so be sure that it is under like research. And many things just run locally and assume, yeah, we're safe. We're only local. We're not like available for like external connections. We're not internet facing. Sometimes companies take it for granted and they're like, yeah, we're safe. But even if you have a web application firewall and so on, you can still target the end users, and your AI might be hacked by targeting the developers and not by targeting the workloads. This is just like one thing I want you to also remember. Local AI is still exploitable. That's like my take.
Okay, so I think we don't really have a lot of time left for questions, so let's move on to the next poll. What is your compliance status currently? I'm gonna poll you on that. 1 second. We already have one ISO. So ISO, SOC, and it seems like either you're not compliant or you're not answering. So I'll assume you're not compliant. So if you're in, oh, here we go, we get some more results. So if you want to be compliant and you want to go through the process, implement the proper security controls, understand how to do that properly, follow the standards, and have an easy time doing it. If you want to conduct a penetration test for your AI implementation or AI product, you can always work with us. We offer all of that. I'm personally not getting anything from saying that this is the most convenient way that I've seen it implemented, especially that I'm on the offensive team and I don't really usually work with the compliance side, but seeing that suddenly being readable to me is great. Something that I haven't mentioned, but you probably have noticed above, at the top, you can book a demo with Scytale. You can go through the process. We will explain to you what kind of services it offers, how easy it makes the compliance process, which is not that simple. Once you open the standard itself and you try to make sense of everything, it becomes pretty apparent that it's not designed to be read easily. So yeah, you can click it, book a demo with us, and we'll get in touch with you later. And that's pretty much it. I hope you enjoyed your time here. I hope we answered everything, any question that was there to answer. Obviously, we can talk about the subject infinitely, right? Because it became gigantic and it's almost impossible to encapsulate everything in an hour. Even leading up while we were discussing what will be included in this conversation, we just kept foregoing things, moving things away, like cutting them out, because it's just endless. So yeah, thank you for coming. Thank you for listening, and yeah.
Thank you for your time, guys, and feel free to reach us on LinkedIn if you have any questions. And yeah, thank you for your time.